Hello, this is Susan Ploss. This is a problem involving positive exponents, negative exponents, and a zero exponent. They're all contained within an algebraic fraction, rational expression. And I'm going to show you one possible way to work this. I'd like to separate out the numeric portion into a fraction, and then anything involving base A into a single fraction, and the same with base B into a single fraction, and base C, as you notice, doesn't have a matching C in the denominator, so I'm just going to place that over 1. Now out here to the right, you see that I've written several rules for you, and I think the first rule I'm going to use is this one that says any base raised to the power 0 is equal to 1. So right here I'm noticing this a raised to the 0 power. So I'm going to set that equivalent to 1. And at the same time I'm also noticing here that I've got some numbers that can be reduced. So let me do a couple of things here at once. I'm going to go ahead and reduce this 20 over 24 using a common factor of 4. So that's going to come down to a reduced form of 5/6, and then out here I'm using my rule a raised to the 0 power is equal to 1. So this part of the problem is can be replaced, a to the 0 can be replaced with 1. So let me start to write some things down. I have 5/6 reduced form here. This is now a squared sitting over 1. And then I'm going to use this rule, let's see, this one over here where I'm doing division of like bases. And when I divide like bases, I subtract the exponents, starting with the 1 in the numerator, subtracting away the 1 in the denominator. I'm going to keep that over 1. And then just copy down to the c to the 5th over 1. All right, so let's see here. What have I got? I've got 5/6. I've got a squared over 1. I think it's important to keep these over 1 so you don't lose track of where you are, whether something is sitting in a numerator or a denominator. And did you notice there that I took the -2 added to the -3 to come up with a -5 exponent? And then out here I'm just copying down c to the 5th over 1. All right, so the last rule that I'm going to need to use here is this: how do you take care of something that's got a negative exponent? So it says any base raised to a negative exponent can be rewritten as 1 over a to the positive exponent. There is another version of that rule. If that negative exponent starts out in the denominator of a fraction, it can move up into the numerator, and also switching from a negative exponent to a positive exponent. We don't need that on this particular problem. So you're going to see me doing putting all of this together into a single fraction bar. In the numerator, I see a 5a squared c to the 5th. Notice all of these are connected by multiplication. And on the bottom, I see the 6, and notice that the base b is coming down, and that -5 is going to switch to a +5. So the final answer, simplified here, is 5a squared c to the 5th sitting over 6b to the 5th. Hope that helps.